Hello, my name is Berta Beltran, and I'm coming to you from the University of Alberta Observatory in Edmonton, Canada. Today is Friday, October 29, 2021, and right now is 8:15 in the afternoon. We are about 2 degrees Celsius in Edmonton, and we have clear skies. I would like to talk to you about planetary nebulae today, and I'm gonna show you this is what our telescope is collecting right now from the sky here in Edmonton. This is what we are looking at. You can see a fuzzy, colorful patch in the middle of a bright field of stars. And so I'm gonna explain what we are looking at right now in more detail. But first, I would like to give you a little overview of the telescope that we are using right now. Our telescope is a digital telescope. It's sitting right now in the balcony at the University of Alberta Observatory and is pointing at the Dumbbell Nebula. This telescope has a mirror at the back to collect the light from the sky, and that mirror reflects the light to a sensor sitting at the front. It's like a camera sensor. Um, and so we when we look at the sky, we are actually able to see what the telescope is seeing by looking through our iPad, the image recorded with the sensor. And that's what you are looking at right now. The beauty of this technology is that the sensor, as I say, is like a camera. It allows us to take long exposures of looking at the sky. So we can integrate light for a long time. You can see at the bottom of the image, it's giving us the name of the object that we are looking at, and it's saying 4 minutes. That means that right now we've been collecting 4 minutes of light to see this image right now. If we were looking at this with a normal telescope and with our eyes, we will see if we were in a dark sky and with a telescope big enough, we will see something similar to this, but without color. Our eyes are not capable of capturing color in very faint light, so we wouldn't be able to see the color. We will just see kind of like a whitish, bluish patch with sort of like an hourglass shape. That is the reason why this is called the Dumbbell Nebula. So the beauty of having a sensor in the telescope is that allow us to see more detail of the objects and it allows us to see their colors. Okay, so what is a planetary nebula? I'm sure you are all wondering. So let's go ahead and explain that. Now, if we stay ourselves on the left side of the picture, we can see that stars appear or start in nebula that are in the sky, mainly composed of hydrogen. Inside the nebula, there is pressure that keeps that tries to gather the hydrogen together, gravitational pressure. And once you have a lot of hydrogen, heat and pressure compress it enough that a nuclear fusion reaction can start in the core of the protostar. When that happens, we have two forces, the gravitational force trying to still pull the material closer and closer, but now we have a nuclear reaction, nuclear fusion reaction going on inside the star that is actually trying to pull it apart. And therefore the star reaches hydrostatic equilibrium and continues burning the hydrogen inside, continues burning its fuel, and just keeps the shape that it is for a long time. Now, once the star starts running out of hydrogen to burn, it starts a process of dying. And what happens is that the core of the star collapses and the outer layers of the star expand, creating what we call a red giant. And as time passes by, the star will shed most of its mass, creating a cloud of gas around the star, which is what we are seeing right now, this cloud of gas that we call a planetary nebula. This cloud of gas is expanding, and the core of the star, the core of the red giant, will still collapse itself into a small hot ball called a white dwarf, which is a very faint star, very hard to see. And that's what we are looking at right now. We have a white dwarf star that we cannot see because it's really faint right now. And then we have this cloud of gas around that has been expelled as the star has gone through through its death because it ran out of hydrogen to burn. Um, Now, do you want to know some facts about the Dumbbell Nebula, I assume? Dumbbell Nebula, also called M27, is located in the constellation Vulpecula. It's not a very well-known constellation in the sky. It's under Cygnus, and right now in Edmonton, it can be seen in the southwest sky, kind of halfway between the horizon and the zenith. Vulpecula in a mythical constellation, it's a fox. So this constellation represents a fox in the mythology of the sky. You can see that in the image on the right, on this in this star chart, there is a little green dot within Vulpecula called M27. That's where the Dumbbell Nebula is located right now. It is 1,250 light years away from us, which is to say that the light that our telescope is gathering right now, those photons have been traveling for approximately 1,250 years from the nebula through space to us. Um, this planetary nebula was the first of the kind to be observed by the French astronomer Charles Messier in 1764 in France. And let's have a last look at the object. It's really beautiful. And now, as we have been collected light for 8 minutes, we can actually see a little bit more detail of the hourglass shape of the nebula with a little bit of wings or lobes coming out to both sides, left and right, on the sides of the red patches in the sky. But anyway, there are lots of planetary nebula in the sky. So right now, I would like to slew the telescope to a different one nearby to where the Dumbbell Nebula is. It's called the Ring Nebula. And I'm just going to select it and move the telescope over there. This telescope is going to slew, and pretty soon in the application, we are going to start seeing the stars moving across. There is a little bit of delay between the telescope image and what we see in our tablet. But in the meantime, I can explain that again, all these stars that you see around the nebula are there in the sky. It's just here in the city in Edmonton, we have a lot of light pollution and we normally don't see them with our eyes. And that's why we need a telescope that integrates light to be able to see all those stars. Um, Now the telescope is slightly reaching the Ring Nebula, which we already can see in the middle of the image. This is kind of what someone that was looking through a normal telescope could see when we see the Ring Nebula. This is just, we will see a white fuzzy patch with kind of like a greenish tone. But if we start integrating light now, so now I'm telling the telescope to start collecting light for a long time, we are going to start seeing more detail of this beautiful Ring Nebula. Um, uh, there we go. So you can see that it's smaller than the previous one. It uses less space in the screen, but it actually looks brighter. Um, um, and it also has kind of like a yellowish ring around and a bluish ring inside. Okay, and so while we let the telescope collect more light and integrate long exposure for us, I'm gonna quickly give you some facts about the Ring Nebula. Ring Nebula is called N57 and is located in the constellation Lyra in the sky. Right now in Edmonton, we can see this constellation in the southwest too, a little bit closer to the zenith than the previous constellation. Lyra, as you can see in the star chart on the right, has a bright star called Vega that is very visible in the skies at this time of the year. And it also has four more stars in the shape of a diamond. M57, M57, the Ring Nebula, is located between the two boron stars of the diamond. In this image, you can see it as a green dot again, labeled M57. This planetary nebula is a little bit farther. It's about 2,567 light years away from us. So again, that is to say that the light that our telescope is collecting right now has been traveling through space for 2,567 years to reach us. And this planetary nebula was also discovered by the French astronomer Charles Messier in 1779. Charles Messier was actually looking for comets. And so he created a catalog of objects that were comet lookalikes so that he wouldn't rediscover them again and again, so that he knew that fuzzy patch in the sky was not a comet. He made a list of about 100 objects that look like comets, and these two planetary nebula are part of those. Now that we've been integrating for a little bit longer, you can actually see a little bit more of the color in the nebula. And I'm going to zoom a little bit. We lose a little bit of the detail when I do that, but we can appreciate the colors a little bit better. You can see that this nebula has an outer ring, a little bit of yellowish color, and then an inner ring that is a little bit more of a bluish greenish color. And the white dwarf star will be inside, but we cannot see it. Another fun fact is that even though these kind of objects are called planetary nebula, they have nothing to do with planets. The reason what they are called like that is because the Charles Messier and the astronomers of the time, when they saw them for the first time, they thought they looked like planets, the way planets do, like Jupiter and Saturn. They look like disks or Uranus, Neptune, that are of a given color and very small objects in the sky. And these planetary nebula kind of look like that. So because they didn't know that they were actually stars that have reached the end of their life, they just called them nebula of the planetary type because they look like planets. And the name is stuck, even though nowadays we know they have nothing to do with planets. And I would just like to finish today's presentation by showing you a sample of images recorded by the Hubble telescope in the space of several planetary nebulae that we can see from Earth. There are so many around. With a good telescope and a dark sky, you can spend a lifetime of studying planetary nebulae. Obviously, as I said, if you only have a normal telescope, you don't see all these beautiful colors that we are seeing here. This is what the Hubble Space Telescope is seeing from Earth. We see similar shapes, but just a whitish, greenish color. I hope you have enjoyed this. Let us know if you have any question, and I'm looking forward to coming back to talking to you soon. Good night. Bye.